Good day, students. This is your Geometry EOC Review Part B, Lines, Angles, and Triangles. So we are still in the first reporting category of congruent similarity like triangles and trigonometry, which is 46% of your Geometry EOC. We will be going over 3 standards for this part of your review. The first standard is GCO28, which is the triangle congruency theorems. Angle, side, 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 and the hypotenuse leg theorem. The second standard that we'll be going over is GCO39, which talks about theorems regarding lines, angles, and angles to solve problems. And the last standard, GCO311, which talks about proving theorems about parallelograms and using those theorems about parallelograms to solve problems. So the first standard we have is GCO28. In your notebook, you already have your key concepts. You're going to take a moment to review these key concepts. These are the same concepts that have been shown to you in topic 2 of your lessons from this school year. So take a moment to review these topics, these concepts, and then you're going to pause this video to see if you can try the first 3 problems for this standard. All right, so let's see how well you did in those problems. We have the first question that says, consider the triangle shown and which can be used to prove the triangles are congruent. So remember, when we're talking about triangle congruency, we are looking at what options have been given to us in the 2 triangles. We already know that 2 triangles are congruent if they have corresponding sides and angles that show to be congruent as well. So one of these out of the 4 triangle congruency theorems show to be congruent. And let's first look at the options that they gave us. We see here that we have marked angle B, and we see that angle B is corresponding and congruent to angle E. And we have angle A here, and we see that's corresponding and congruent to angle D. We also have side AC, which is congruent and corresponding to side DF. So I have 2 angles and a non-included side. So that tells me 2 angles and a non-included side shows me that is for angle side, which is the triangle congruency theorem that we can use to prove that these 2 triangles are in fact congruent. Okay, so we have number 2, which says, given figure ABCD with diagonal AC, we have 2 pairs of sides that are corresponding and congruent, AB and DC, and we have BC and AD that are congruent. They want us to complete the proof showing that triangles ABC and CDA are congruent by selecting the reasons for the last 2 statements of the proof. So what we like to do is to first identify the information that's been given to us by highlighting or marking our figure. So we already have the diagonal that's been given, which is AC, and it also tells us that we have sides AB and DC congruent, and we have sides BC and AD congruent. So we've already stated that's given here in the problem as to be true because it simply says here that it's a given. All right, let me mark that with a different color so you guys can see it. So it's already given that this statement is true. If we're looking at AC, it's congruent to AC. Remember, we have 2 triangles here. We have triangle ABC and we have triangle CDA. So remember, we're trying to prove that these 2 triangles are congruent. So we're trying to prove that they have corresponding parts that are congruent. And as we can see, AC is shared between the 2 triangles. So we can say that this statement of AC, segment AC being congruent to AC, is true by the reflexive property. All right, so remember, the reflexive property just states that you have one part of a figure that's congruent and corresponding to the same part in another figure. All right, so now that I see that AC is congruent to AC, we can now go ahead and state that the 2 triangles are in fact congruent. And why are we stating these 2 triangles are congruent? Well, I can see that I have 3 sides in triangle 1, AB, BC, and AC, are corresponding and congruent to 3 sides of triangle CDA, AD, CD, and AC. So if I have 3 sides of one triangle corresponding and congruent to 3 sides of another, we can automatically say that this is the side triangle congruency theorem. All right, so let's look at number 3. Number 3 states that Anaya has repeatedly stenciled the triangle shape shown on her bedroom wall. Her best friend, Daniela, wants to copy the same exact shape on her bedroom wall. Which statement has sufficient information about the triangle for Anaya to give to Daniela to guarantee Daniela will have the exact same triangle? All right, so remember, if I'm copying a triangle and I want that triangle to have the same shape and same size from one triangle to the next, then that means that those two triangles have to be congruent. And in order for two triangles to be congruent, we have to make sure that their corresponding parts are congruent as well from one triangle to the next. So those parts include a sides or angles. All right. So remember, we do have several angles and side theorems that we can use. We have side, side, side. We have side, angle, side. We have angle, side, angle. Oops. Nope. Angle, side, angle. And we have angle, angle, side. All right. So as long as the copying of the triangle falls into one of these categories where we can show that we have some congruent sides along with some congruent angles to be congruent and corresponding, then it makes sense that we can go ahead and copy that triangle for what it is. All right, so the first one, construct a triangle with angles whose measures are 33, 42, and 105 degrees. Well, 3 angles of a triangle are not going to be sufficient enough information to show that the triangle is necessarily going to be congruent because it's missing some information about the sides. So we can't use that one. Construct a triangle with sides of measures that measures 22 inches and 27 inches, where the included angle is 105 degrees. So they're talking about this side here of 22 inches and this side here of 27 inches, and then saying that the included angle is 105 degrees. Well, let's think about this. If I have 2 sides and an included angle, that actually falls into one of the categories. So for right now, we're going to say that this is a true statement. If I copy it in that respect, then I'm going to get a congruent triangle. But let's just read through the other ones just to make sure that we're correct. Construct a triangle with sides of measure 39 inches and 22 inches and a non-included angle measure of 33. So the fact that it said non-included angle with 2 sides, we don't have any theorems here that have non-included angles with 2 sides, so we know automatically that that's not correct. And then last one, construct a triangle with a 105 degree angle opposite from the side of length 39 inches, where the remaining 2 sides differ in length by 5 inches. So yes, we do have a 105 degrees across from the 39-inch side, but the fact that it says with the remaining 2 sides differ in 5 inches, that could be any length. That could be 25 and 20 inches. Okay, so I just gave you a counterexample that just shows that I can draw another triangle with 2 different side lengths, even though we have some information that's true. So we know that that one's incorrect. So the one that we know for sure that is going to provide us with a congruent triangle is this second statement here, where I have 2 sides and an included angle of the measure of the original triangle. All right, so let's look at our next set of standards, which is GCO39, which is also assessed with GCO310. And these 2 standards primarily look at some theorems and some properties of angles and triangles. So GCO39 primarily looks at vertical angles and angles that are created by parallel lines and transversals. And we can also talk about perpendicular bisector theorem in this standard. GCO310 looks at properties of triangles. So we have some properties about isosceles triangles and equilateral triangles, and the interior-exterior theorem about those angles of triangles. So you're going to take this opportunity now to pause the video, look at the key concepts in your notebook about these 2 standards. And then once you have looked at those standards, you're going to now go ahead into your practice problems and try out those problems. So you can pause the video now, look through those key concepts, try out the problems, and then come back and we'll review the next set of 3 problems. All right, so let's look at number 1. So number 1 says in the diagram below, they give us some information about the two lines AB and line segments AB and CD, that they are parallel, and then we have line segment GE and GF are drawn from those parallel lines. They tell us that we have angle measure EFG at 32 degrees and angle measure AEG at 137 degrees, and we're trying to find the measure of angle EGF. So I like to mark up my problem just to make sure that I know what I'm looking at. So first they tell us that we have two lines that are in fact parallel, so I'm going to mark that these lines here, AB and CD, let me move that over so that way we have them in the right place. So let's say AB and CD, we know they are parallel. They gave us EFG, so angle EFG is here, is 32 degrees. And they gave us AEG, so AEG is this angle here, and that's 137 degrees. Okay. The angle that we're trying to find is angle EGF. So this angle right here is the angle in question. All right. So there's a couple ways that we can go about doing this problem as far as how to get our answer. For me, let's start with first looking at what they gave us for angle AEG. So this 137 degree angle, I see that it's on the same line of AB. So I can automatically find this missing angle here, right, by taking 180 and subtracting 137. So when I do that, I actually get 43 degrees. So this angle right here tells me that it is 47 degrees or 43 degrees. So let me go ahead and mark that angle as 43 degrees. And then now that I have that angle here, given the information that I know about triangles, I know all the angles in the triangle are a sum of 180 degrees. So if I take 43 and add that to 32, I actually get 75. So I know these two angles are 75 degrees together, and I can take that 75 and subtract it from 180. So 180 subtracted by 75 gives me 105 degrees. So that's how I got my answer. You could have done it another way, where you could have maybe found this angle right here as being alternate interior angles with the 32 degrees, and maybe saw that this angle right here was 43 degrees after finding that one, and that was also alternate interior angle, and then find the missing angle by saying all three of these angles lie on the same line. I mean, there's so many ways that you could have seen this problem. If you see it a different way, that's cool as well. The important part is coming to the correct answer. All right, so let's look at number 2. So number 2, we have a proof. The proof says they are giving us that the two lines M and N are parallel with a transversal of P, and we are trying to prove that angles 5 and 4 are congruent. So once again, we're going to mark up our problems. We see here that we have two parallel lines, so let's mark those. Line M and N are parallel, and then of course we have our transversal here of P, so I'm going to identify that by highlighting it. And then we're going to identify the two angles that we're trying to prove that are congruent, which are 5 and 4. So I automatically see that 5 and 4 are alternate interior angles, but we need to use some information around those angles to prove that they are actually congruent. So they already give us that the two lines are parallel with transversal P, that's given to us. And then we need to fill in the blanks with the table that's provided here of either the reason or the statement to go along with the input that we have. So they give us that angle 8 and 4 are congruent. So angle 8 and 4 I see are on the same side of the transversal, okay? And they are in the same position. So same side of the transversal, same position tells me that those are corresponding angles. So we can get rid of this one in our table. And then they tell us something about vertical angles as being the next step. So if the next step is talking about vertical angles, then that means it has to have something to do with angles 8 and 4. So that means I'm looking at angles 8 and 4 and seeing how it relates to angles 5 and 4, right? So angle 8 I see is vertical to angle 5 here. Okay, so let me use the same color. So let's go back and use that purple. So angle 8 and 5 I see are also vertical angles. So that tells me here that I can, as a statement for vertical angles, I have angle 5 is congruent to angle 8. Okay. So now that I have angle 8 and 4 congruent and then angle 5 and 8 congruent, that gives me some relationship that I can now link these two angles together. So if 8 is congruent to 4 and 5 is congruent to 8, then what links 5 and 4 together? Well, that would have to be angle 8. Angle 8 is what angle 4 and 5 have in common. Since angle 8 is what they both have in common, then that makes these two congruent based on what they have in common. So remember, anytime that you see two statements that have one of the properties in common, that leads us to show that the last statement is going to be true by the transitive property. Okay, so that makes 5 and 4 congruent by the transitive property of congruency. All right, number 3, again, we have a proof. And this proof gives us that line JM is a perpendicular bisector of line LK. And we're needing to prove that J is equally distant or equidistant from points L and K. So again, we're going to highlight the information that they gave us. We see that we have line JM here, and we see that it is perpendicular to line segment LK. It's a perpendicular bisector. So if it's a perpendicular bisector, that means we have a 90-degree angle created here. And we want to prove that point J is equally distant from K and L. All right, so they already gave us that the given is true. It was given to us in the problem. The next statement we are trying to fill in, or the reason that we're trying to fill in, is from the statement that angles LMJ and JMK are right angles. So we already have JMK labeled as a right angle, and they're telling us the other side here is true for a right angle. Well, why would this be true? Well, obviously that is the definition of right angles. It is the definition of right angles because it just told me in the previous statement that the two lines are perpendicular. If I have two lines that are perpendicular, then they form two right angles, or in this case, they form 4 right angles, but in this case, we're looking at only 2 for this triangle. So we can get rid of this one here. All right, so the next one we're trying to find is the statement for the reason that all right angles are congruent. So if I have two lines that are perpendicular and they create right angles, and now the reason is all right angles are congruent, then that only leads me to believe that these two angles, L and J, if they're both right angles, are congruent to each other. Right, so these two angles are congruent. All right, so we also see here that it's given to us for the statement of reason that lines LM and KM are bisectors, right? So if I have a perpendicular bisector, that means it bisects right at the center of the line segment LK. So that means L to M is the same distance as from K to M. And then now we're trying to find a statement for the reflexive property of equality. So remember, reflexive property means that you have one part that can be found in 2 different figures. So if I'm looking at this as 2 triangles, right? I have triangle number 1 on this side and triangle number 2 on this side. What's the one thing that both of these triangles share? Well, that is side JM. So JM would be the side that they both share. So JM, let's use it the same color. So we have JM is congruent to JM. So now we have these two triangles, LMJ, which is triangle number 1 on the left, and KMJ, triangle number 2 on the right. These two triangles are congruent by side, angle, side, because remember we have side LM and side KM congruent, and then we have side JM congruent, and we have two right angles in between of them. So we have two sides and an included angle for both of the triangles. So that's where we get the side, angle, side from. So now that I know that these two triangles are congruent, what can I say about the other corresponding sides of this triangle? Well, I can also say that side LJ is congruent to side JK, and we can say that is by the corresponding parts of congruent triangles are congruent, or CPCTC. If I have congruent parts of one triangle corresponding congruent to other parts of the other triangle, I can automatically say that the other parts are also congruent. So now I've just proven that point J is in fact equally distant from point L and K, and that's by the definition of being equally distant. All right, so the last standard that we're looking at today is GCO 311, and this standard primarily deals with the properties of parallelograms and special parallelograms. So we're looking at theorems and properties that deal with rectangles, rhombus, and squares, and how that relates to the properties of parallelograms. So at this time, I want you to go in your notebook and review the key concepts for these types of figures, and then you're going to move on to your practice problems. So you're going to pause the video, practice these questions on your own, and come back and we'll review them together. All right, so we're going to look at example number 1, and example number 1 says that we are given a parallelogram ABCD and that we are needing to prove that angles 1 and 2 are supplementary. So if you recall, one of the properties of a parallelogram is that we have consecutive angles that are supplementary, and remember, supplementary means that we have two angles whose sum is equal to 180 degrees. So we're going to do this proof by a paragraph proof, just by filling in the blanks. So the first sentence states that we have the given information, which states that we have a parallelogram, and the names of the angles are in consecutive order, angle 1, 2, 3, and 4. The next sentence states that we have opposite angles of a parallelogram are congruent. So we know this already as one of the properties. So that means that we can say that the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. And of course, we can say this by the definition of congruence, right? So if we have congruent figures and congruent parts in a figure, then obviously that's the definition of congruence. So the next step is to realize that every single quadrilateral's interior angles equal 360 degrees. So that means the measure of angle 1, 2, 3, and 4, and when I add them all up, they equal 360 degrees. So we're going to use the substitution property to come up with a equation. So you're saying, well, how are we going to do that? Well, we already know that angle 1 is the same as angle 3. So we can plug in 1 here. And we already know angle 2 is the same as angle 4. So we can plug in angle 2 here. So I can rewrite this equation as the measure of angle 1 plus the measure of angle 2. So we keep this first part. But the second part, I'm going to replace 3 with the measure of angle 1. And I'm going to replace 4 with the measure of angle 2. And now that's going to equal 360 degrees. So as you can see, we're just going to now group our like terms. So we have 2 measure of angle 1s, and we have 2 measure of angle 2s. So when we group those together, we get 2 times the quantity of the measure of angle 1 plus the measure of angle 2 equals 360 degrees, right? So now that we have that information, we can say by the division property, because remember, we're trying to show that these two angles are supplementary, that they equal 180 degrees. I'm going to divide my 2 on both sides. So when I divide my 2 on both sides, it cancels here, But on the right, I get 180. So voila, ladies and gentlemen, look what we get. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And that for sure tells me that these two angles are supplementary. All right, so let's look at number 2. So number 2, they give us a rectangle, and they tell us that diagonals FH and GI intersect at E. And they give us some information about each of these segments. So FH and GI, they intersect at E. And we know that from I to E represents 3x plus 4, and from E to G represents 5x minus 6. They want us to find the length of FH, this full length right here. So recall the properties of a rectangle and its diagonals. We know that the property states for a rectangle that diagonals are congruent. That means they're equal. Not only are diagonals congruent, diagonals bisect each other as well, because remember, it is also a parallelogram. So we can set up some equations here. So the first equation that we can set up is that I know that segment IE is going to be equal to segment EG because we have a bisector point right here of E. It says it intersects at E. And if the two diagonals bisect each other, that means that the two segments are, if the two diagonals bisect each other, then that means that these two segments IE and EG are equal. So we're just going to plug in what they have, 3x plus 4, that's equal to 5x minus 6. And then now we're just going to solve. So I'm going to bring that 3x over, so that means I have 2x minus 6. I'm going to bring that 6 over, so I have 10 equals 2x. And then when I divide both sides by 2, I get 5. So x is equal to 5. Now remember, the whole purpose is to find the length of FH. Well, we already know that FH is a diagonal, and we already know diagonals are congruent. So that means diagonal FH is congruent to diagonal GI. So all I got to do is plug in the value of x into the two expressions that I have and add them together. So when I do that and I plug in, I get FH is going to be equal to IE plus EG. So let's plug in. So that means FH is equal to IG was 3 times 5 plus 4, and then EG was 5 times 5 minus 6. So FH, we have 15 plus 4 plus 25 minus 6. So all in all, we have 15 plus 4 is 19, 25 minus 6 is 21, so I have FH as being 38 units. So that is the length of FH. All right, so let's look at this last one here. It says we are considering the parallelogram that's given to us ABCD with point X at the intersection of diagonal segments AC and BD. Evelyn claims that ABCD is a square. Select all statements that must be true for Evelyn's claim to be true. So remember, when we think of a square, we think of this as having all properties. Just can't spell. All properties. Sorry, guys. All properties of parallelograms, rectangles, and rhombus. Okay, so that means it has everything. So we have to make sure that the information that is given here satisfy all the properties of parallelograms, rectangles, and rhombi. All right, so let's first look at what was given to us. They said that we have point X at the intersection of diagonal AC and BD. So this is our intersection. So if this is the intersection of diagonals AC and BD, and we think about diagonals, we already know for a parallelogram Diagonals bisect each other, so these two segments and these two segments are congruent. We already know from a rectangle that the diagonals are in fact congruent, so we can say that these diagonals actually equal. Let's try that again. That these two diagonals actually equal each other. Okay, so that's one thing. All right, so let's look at the information that's given. We have AB is congruent to AD. So AB is one of the sides of the squares, and then AD is one of the diagonals. Not any time do we have a property that says that the side of a parallelogram is equal or congruent to the diagonal. So that's no. AD is equal to AB. So AD is a side, AB is a side. We already know that the sides of a square are congruent, so if they're congruent, they're equal. That's true. So that's by congruent sides. All right, AC is equal to BX. So AC is the length of one diagonal, and BX is half of one of the diagonals. Neither one of the properties for parallelograms, rectangle, or run by say that the diagonal is equal to half of the diagonal. So that doesn't make any sense. All right, the next one says that we have the measure of angle ABC. So ABC, this angle right here is not equal to 90 degrees. Well, we know that's not true because all the angles in a square equal 90 degrees. So that's not true. This actually is equal to 90 degrees. So that is true. The measure of angle AXB is 90 degrees. So they're talking about this angle right here that's created by the two diagonals. Remember, square holds all the properties of all the parallelograms. So the one parallelogram that has diagonals that are perpendicular, meaning that they intersect and create a 90-degree angle, is a rhombus. So we know that a rhombus has diagonals that are perpendicular. So we know that that statement is true. So we have the second and the last statement to be true. All right, ladies and gentlemen, that is it for me. So your responsibility now is to go to quizzes and complete today's practice for the geometry EOC class practice for part B. Remember, your goal is to get 90% or better. That shows that you are proficient and mastering the skills for this lesson. Don't forget about your IXL weekly project for the 3 skills per week, and make sure that you are practicing on Imagine Math. Good day, students, and I will see you in class.